Hi, hello everyone. Um, Welcome to this webinar, Bringing SaaS Simplicity to Proactive Support and Live Threat Updates. This is a webinar we're going to talk about NSX Advanced Load Balancer, also known as Avi Networks. So we were acquired by VMware almost 2 years ago. And today, Rahu will talk about Avi Pulse, which is a cloud service that provides proactive service and security threat updates. Now, before I turn to Rahu, who is a product manager for Avi, I'm actually just going to state a few, simple rules for the webinar. The first of all, that this webinar is getting recorded right now, and we will also send an email with the slides and recording after the webinar. So if you find the content helpful, feel free to forward it to your coworkers so that they could take a look. Now, second of all is you could use the Q&A window to ask your questions. Now, Rahul will do a live presentation as well as demo, and then afterwards I will ask these questions live to him, and I will answer some of the questions offline, through the chats as well. So keep the communication going during the duration of the webinar. Okay, now without further ado, I'm gonna let Rahu to take the stage. Hey Rahu, you're on.
Perfect. Thanks, Lei. Welcome, everybody. Thanks, Lei. And let me begin this presentation by actually asking a question to everybody. How many of us here have spent endless hours troubleshooting issues, trying to root cause a problem, wondering if applications are functioning properly, feeling anxious about the next go live, worrying about sort of operations and in general managing all of the applications, feeling unsure about the security posture for your applications, and finding it hard to keep up with the ever-changing threat landscape. Now, we hear you. This is a real problem, and we understand delivering on ever-increasing demands of businesses while managing security and providing the required level of SLAs and SLOs is an incredibly daunting challenge. Talking with our customers, though, we have seen patterns emerge, and these patterns emerge throughout the application lifecycle. We know that procuring is slow, it's tedious and expensive. It causes friction to business agility. Securing applications is incredibly hard, especially in this hybrid world that we are living in. Operators are running blind and desperately want visibility. Managing 99% plus SLOs is no easy feat. And to do this, operators desire a highly efficient monitoring and support experience. Now, is there a place where customers can find solace and figure out if they can deploy tactics to combat these problems? Now, it so happens that load balancing and application delivery happens to be in a sweet spot to address most of these challenges, be it load balancing being placed in a strategic location, being able to see inline traffic, which it can use to get real-time data and make decisions out of it. It's a great place to have as a security checkpoint to enforce security rules to protect your applications. Along with that, Avi's modern architecture brings in efficiencies that profoundly aid in delivering solutions to these challenges. Now, let me give a quick primer on Avi's architecture for the benefit of those who are new to how Avi works. Avi Networks Vantage platform, now known as VMware NSX Advanced Load Balancer, is a modern software-defined elastic application delivery fabric. It is composed of a central control plane and a distributed data plane. Avi controllers provide a centralized intent-based policy engine which delivers full lifecycle management for all the applications. Now, Avi service engines are the load balancers. They implement the data plane, which can be deployed anywhere, natively in a fully orchestrated fashion by the Avi controllers, on-premise or in the public clouds. Avi Controller consumes application intent via REST APIs and strives to realize that intent, almost like a Kubernetes cluster. As an example, Avi Controller would create Avi service engines when required, acquire IP addresses for VIPs as an example from an IPAM like Infoblox, register into DNS like Azure DNS or Route 53, manage application certificates, and so on. And all the user ever needs to really do is to simply convey the intent. Now, Avi Controller also eliminates the problems of over-provisioning and overspending by scaling load balancers elastically based on real-time traffic. It also provides a self-healing fabric. An example is if a service engine fails, first applications are dynamically moved to other available Avi service engines, ensuring that the required capacity for the applications is always available. And also creates new Avi service engines to replace the failed ones. Avi provides a single point of control and multi-cloud support. This enables a universal solution for traditional, modern, and cloud-native use cases across all environments. Applications can reside on any cloud, and Avi controllers would provide the same level of automation regardless of where the application is provisioned. It provides rich performance monitoring and visibility into client, security, and application insights that simplifies troubleshooting and also automates decisions. This makes up a powerful software-defined platform, on top of which Avi delivers truly enterprise-grade load balancing, GSLB, application security, WAF, and container ingress services, all stitched together with the powerful analytics and observability engine. Now, with that, let me introduce Avi Pulse. What is Avi Pulse? Avi Pulse is a cloud-delivered service which has been designed specifically with the goal to bring SaaS simplicity to application delivery. Pulse will provide services aimed at eliminating customer pain points around supportability, proactive monitoring, delivering security at scale, licensing and billing, operations and visibility. And Avi Pulse will enable globally distributed Avi deployments to tackle these hard problems simply and securely, no matter where they are, be it in the data center, in the public cloud, or at the edge. Now, with Avi Pulse and Avi Controller connected together, we can enable powerful experiences to our customers. Customers, the pain points that we had discussed early on, customers can leverage Avi Pulse to alleviate a lot of the pain points that they are currently seeing. And let us explore a few use cases in today's webinar. I will be talking about two services that we have onboarded on Pulse today. One is centered around supportability, and second is around a couple of live security threat feeds. We will be taking a look at a couple of live security threat feeds. Now, as mentioned, supportability is immensely important. Monitoring applications, monitoring the health of infrastructure, recognizing when a failure happens, and then remediating the problem as soon as possible, as well as figuring out the root cause analysis of what happened so that it doesn't happen again, is incredibly important. Now, to that, let's take a look at how a typical issue is addressed today with respect to load balancing. Imagine it's nighttime and our load balancing admin is fast asleep. A problem occurs due to a load balancer going down, and this impacts a few services, and our admin gets a call middle of the night. Admin wakes up and now needs to find out where this problem occurred, which appliance is impacted. Once that is found out, admin then needs to log into that appliance and try and find out what happened, and then request for a tech support bundle to be created. Then needs to wait until the bundle is created, and then downloads the bundle once it is created. Admin then would have to log in to the customer support portal of the vendor, would need to create a case and add all the necessary information for that case manually. Admin then finally uploads the bundle that was downloaded, which might be hundreds of MBs. And we haven't even looked at remediation yet. As you can see, there are various pain points in this process. Identifying where the issue happened is not an easy task. Gathering data takes a lot of time and might be inaccurate or incomplete to solve the issue. Interaction with multiple systems is tedious, and a lot of information needs to be manually entered, which is highly error-prone. There has got to be a better way of solving this, and Pulse aims to make this simple and make this a thing of the past. So let's walk through two specific workflows that Pulse will enable around supportability, which is aimed to essentially tackle this problem. The first one is what we call in-product case creation. And let's walk through the scenario that is shown here. In this scenario, Avi controller is registered with Pulse. And just like before, it's nighttime and our load balancing admin is fast asleep. A problem has occurred and the service engine, Avi service engine has gone down, which impacts a few services. And just like before, our admin gets a call. Admin wakes up and this time simply logs into the Avi controller. As Avi controller manages all of the service engines, it is much easier to find out where the problem occurred. Now, instead of going through the cumbersome process described previously, admin simply creates a case right from the controller. Admin also simply indicates to collect a tech support. Avi controller self-healing fabric in the meantime would have already restored the service failure automatically and remediated the problem. And admin can now go back to sleep. Now, behind the scenes, controller uses Pulse APIs to create a support case, attach metadata such as controller version, ecosystem, etc. automatically. Controller will also automatically initiate a tech support bundle because the user initiated it. Once the tech support bundle is ready, controller uses Pulse APIs to upload the bundle and attach it to the case that was generated. Now, with this workflow, what are the key takeaways that we see? With Pulse, customers get a much better experience through a single-step case creation workflow. And case creation takes literally a matter of seconds. A lot of metadata is automatically filled out, which reduces fat finger errors. And Avi's self-healing fabric would have remediated the problem in most cases automatically. Now, Pulse takes this one step further, which we call as proactive case creation, enabling truly a zero-touch support experience. And let's see how this plays out. Just like before, Avi controller is connected to Pulse and has enabled this time proactive case creation. And just like before, it's nighttime and our admin is fast asleep. A problem happens and the service engine goes down, which impacts a few services. Now this time, behind the scenes, upon detecting a service engine going down, Avi controller automatically uses Pulse APIs to create a support case. Metadata such as controller version, ecosystem is automatically filled out. Controller also initiates a tech support bundle. It collects the core dump and collects any relevant information that is needed for the case. And once the information is ready, once the tech support bundle is ready, controller will use Pulse APIs to upload the bundle and attach it to the case that was created. And just like before, in the meantime, Avi controller self-healing fabric would have restored the service failure automatically. The issue has been remediated and VMware support has been notified with all the relevant information that is needed to debug the case. And by the way, our admin is still deep asleep. He was never bothered. He would have gotten a notification, but now the entire case creation workflow as well as remediation is fully automated. Now, this is incredibly powerful. And Pulse provides this zero-touch support experience for customers. And customers can implement their own alerts based on metrics, based on events, which dictate their critical KPIs, and that can be fed into the system. So it's not just SE down, but any perceived issue that a customer feels like deserves a support case can be made to fit into this workflow easily. The second service that we will talk about today is centered around live security threat updates. Now, why is Pulse a good point to deliver live security threat updates to controllers to protect applications, essentially? And the reason is multifold, actually. The controller deployments are in distributed, disparate environments, public clouds, data centers. Even within data centers, they are distributed in VMware environment, on OpenStack, on bare metal, etc. And they are very hard to manage cohesively for NetOps and SecOps teams. Threats are evolving in real time. They are constantly changing. And applications need protection from multiple attack sources / vectors. And to aid with this problem, Pulse is a great fit to deliver live security threat feed centrally and build intelligence on top. In today's demo, we will be showcasing two such threats that are delivered through Pulse. One is IP reputation data, and the second is application-specific signatures for WAF. And Pulse is bringing in these live security threat feeds from various industry-leading security partners and VMware in-house to deliver security to the applications. Now, the picture that is shown here showcases a request pipeline that shows various points at which different security enforcement could be applied. It shows a request coming in, and the request is handled by a Avi service engine, which is running an application which is enabled with WAF, hence the shield. Once the request comes in the request pipeline, we will first sift through allow, deny. And in this stage, IP reputation data kicks in. Pulse is using Webroot as a security partner to get IP reputation threat feed. And IP reputation threat feed gets updated almost every 15 minutes. And it provides protection from bad IPs, such as spam, bots, scanners, etc. Now, customers can simply create a policy blocking spammers, scanners, bots, etc., from entering their application simply through this integration. The second piece is the application-specific signatures, which we have partnered with TrustWave to deliver application-specific signatures. There are over 3,000 application-specific signatures, like Drupal, WordPress, you name it. And these application-specific signatures have got curated rules tailored to those applications. And the aim of this is to reduce or eliminate false positives, actually, and also gain a lot better performance as compared to sort of the plain CRS rules, which scans for a wider variety of threats. Now, these application-specific signatures get updated almost every day. And from a consumption standpoint, once the service is enabled, these threat feeds come into the controller automatically, and they get inserted into the application pipeline, into the request pipeline automatically. So an instance is IP reputation feed is coming in, and customer has selected to block bots and scanners. And every day bot IPs and scanner IPs are changing. It doesn't matter, because through the live threat feed, the database for IP reputation is constantly being updated. And therefore, the request pipeline is constantly being protected. Also, lots of new threat feeds are incoming, so stay tuned to those announcements. With that, let me move to a live demo that we will be doing, and in this demo, it's essentially a two-part demo, which we will demonstrate both aspects of the services that we spoke today. One centered around security, and the second centered around supportability, and we will specifically show how zero-touch support will look like. So with that, let me move to a Avi controller. I have my Avi controller up and running, and once we log in to the Avi controller, I have set up an application called Pulse Demo. This application is a web application, and it has been protected with Avi's WAF. Expanding on this application, we would see that Pulse Demo is the virtual service which has the VIP. It talks to a backend pool which has a bunch of servers. This application is residing on two Avi service engines, which are the data plane entities. This is a scale-out fabric with the same application being serviced by two service engines at this time, which can be grown at any time as user desires. Now, before we get into the specifics of the application, let me go into administration settings in Pulse. And we have registered this controller with Pulse. And for registration, the customer would need their My VMware credentials to register. Now note, credentials are neither stored by controller or Pulse. It just uses My VMware as IDP and uses access tokens to talk to controller. Once it is registered, customers can enable opt-in to the services that they want to consume. By default, all services are disabled, and customer needs to come in and select the services that they want to consume. For today's talk, IP reputation and application rules are the services that we will be looking into. With that, let me go back to the virtual service that has been set up. Peeking into the virtual service, we will see the virtual service is running on an IP and it's registered with DNS. It's being serviced by two service engines and is protected by WAF through this protect WAF. I have WAF in detection mode currently. I haven't put it in enforcement mode for demo purposes. Looking at the analytics screen of the application, we can see that application is servicing traffic at about, and latency is about 15-16 milliseconds per request. And it is servicing currently around 700-600 requests per second. Let's go to the logs screen. These are the client traces that the service engines are sending in real time for the application. Now, Avi divides client traces into two specific buckets. One is called significant logs, and the other is non-significant logs. Non-significant logs are all of the 200 OKs and when application is doing just fine. Significant logs are logs that customers would need to pay attention to. Logs like 404s, etc., would be marked as significant. Let's look at a sample log. This sample log shows a client coming in from this IP and the port using RSA and TLS 1.2. And the RSA is a PFS, has PFS enabled. It hits the virtual service, and this particular server is selected. A GET request for images for this particular image is done, and the server services that image with a 200 OK. The request is serviced by this specific service engine, and then we can actually see for each request what are the headers that came in, and this is the registered DNS for the application. And we could see that the client IP got forwarded to the server. using the X-forwarded for header as well. We can see the headers that came in and the headers that are sent out back to the client. Now let me just run a sample request to the application just to make sure the application is functioning. We see this homepage that is sitting behind the application, and this shows that it's working fine. However, on a little digging into the application logs, we see there are a couple of requests that are being made with a certain number of parameters. And we can see that this particular request is calling a parameter and is trying to inject a PHP script into the server. Now, if this was a WordPress application, for example, this would be a vulnerability, which unfortunately is not being caught by WAF currently. It is marked as passed by WAF, even though this is a vulnerability. Now let's use application signatures feed that we're getting, and let us try and solve this problem. Let me edit the application and go into my WAF policy. Go into my application rules. As you can see, I have it in detection mode right now. When I go to application rules, we can simply select the application that we're running. And once the application that we're running is selected, we can simply save that. Now you could see that there are numerous applications that are running here. There are well over 3,000 applications running. The 3,000 applications signature is being sent by TrustWave, and the threats and the signatures are updated almost every day. So for this threat that we are simulating is for a WordPress application as an example. And let me go ahead and save that. And let's see what happens. As soon as I save the application, we can start seeing that some of the requests are being marked as flagged. When I look at this particular request, it says it is flagged. And the significance is because there is a WAF match. And WAF matched the transaction because an application rule group has hit. Digging deeper into what was that hit, it shows that an arbitrary file upload in the Gravity Forms plugin for WordPress is being attempted. And it's attempted by the name argument, and the value is the script is the threat upload.php, which we can see in the query parameter that is being sent as part of the URI. Now, because this is in detection mode, it's just flagging it. But if we had the WAF in enforcement mode, this request would have been blocked. Now, let me go back to, let me actually show the IP reputation feed that we are getting from Pulse. Going into templates, security, IP reputation, you could see IP reputation is coming from Webroot, and this is the database which you can actually search for IPs right here, or you can also send a change request if you feel that any IPs have incorrectly being marked as something. Now, using this threat feed, I'm actually going to protect my application. Now, unknown to us, there have been a bunch of IP addresses hitting this application with a spam that belong to the spam IP threat, and we haven't protected against them. Those client IPs are coming in, and the application is servicing traffic to them without flagging those IPs. What we will do is we will try and protect this application from those IPs. So for that, we will implement the HTTP security policy in today's example, but this could be implemented in various stages of the request, right from the network, right on the TCP layer, to HTTP layer on the request side, as an example. So I'm going to use my IP reputation database that is being updated, and let me call this as a spam protect rule, because I'm going to protect my application from spammers. I will use an IP reputation database, and I will try and find spam source IPs. If any IP is coming from a spam source, I want to block it. And for this purpose, let me just send a response from UI saying you will get a forbidden, and I will insert a custom error page for demo purposes. And once that's done, I will hit save. Now, before we look at the traffic, actually, let me go back to the security rule that we just created. And you can see that we could have added protection against various attack vectors. Various sources of IP reputation are available. A botnet was mentioned in sort of the when we talked about this service. There's phishing, scanners, etc. Right. So let me go back and see if we have caught any bad actors. And instantly we see there are a lot of 403s that are coming in. And this is because we created this rule and sent a 403 if the IP belongs to a spam group. And we could see here that this IP address has matched the spam rule that we created. It matches in the database, it matches the spam IPs group, and the application is being protected because here, if we notice, client gets a 403 and instantly the client gets a 403 from the LB and there is no server that is selected. So the load balancer essentially is servicing the request and is sending a 403 right from the LB, not even contacting the server, which is the right thing to do. And now if we look at the same application and try to access it, because this browser is part of the spam IP, it is showing that you cannot access the application and you're getting a 403 page. Now, this is incredibly powerful, where you could use just a few simple policies and you could protect it. You could protect your application in various stages of your request pipeline. Lei, do we have any questions at this time? I would be happy to take a few questions before we move to the zero touch support demo.
Yes. So a lot of the question is about how to get this this feature. This question from Palak. She's asking if it's free for existing customer.
That's a great question, Lei. Thanks, Palak, for the question. Yes, all existing customers and customers who want to experiment with Pulse can get access to Pulse. Customers would require my VMware credentials to sign up for Pulse and an Avi entitlement to be able to access Pulse services. Once customers have that, the sign up workflow is incredibly simple. You just say register. If I go into my administration settings and Pulse, we just go into registration, and actually let me bring up a Pulse getting started, and let me send this KB as well. Here we just go from the UI, say register. It will take you to my VMware IDP, and then you just enter your my VMware credentials, select your account, the user that has registered with my VMware. We will list out the accounts that the user has. The user then selects the services that they intend to consume, and that's it. You are ready to consume services from Pulse.
Cool. Another question is from John Smith. He's asking, do you guys support bot feed?
Bot feed?
Yes.
That's an excellent question, Lei. And going back to this slide that I had, live security threat updates as a almost like a bucket service, which encompasses all of the threat intelligence that we will be providing. Bot detection is a service that we will be providing in a couple of months. We are actively working on bot detection, and both from a Pulse standpoint and implementing that on Avi controller itself. So stay tuned. In a couple of months, within a quarter, we will have bot feed live.
Let's take one more question before you do the second part of your demo on support cases. From Manoy, without Pulse, how you guys use to track IP spammers and signatures?
Yeah, that's again an excellent question. So on Avi, we have the policy engine, which goes through the various phases of request, and usually the way customers would handle this is they would create what we call as IP groups, and once they create IP groups, they could fit the essentially spam IPs and bot IPs, etc., into IP groups. Now, this IP group, as you know, is essentially a static resource. It has static IPs, and now they would use this IP group into the request pipeline. And as you can see, the problems with this is, yes, it provides a functionality to let's say embargo a particular country, or provide maybe that you have a static list of IPs that you want to block. But looking at the web threats that we're seeing, and the threats evolving almost every minute, this is really incredibly hard to protect against web threats. But customers used to use this workflow to protect their applications, although as you can see, it is incredibly challenging.
Yeah, and just to add to Rahu's point that the Avi Pulse actually have curated real-time threat updates. That's one of the features that we support. And then he has another question: will new customers be charged separately for Pulse?
New customers, all existing customers can enable Pulse with their existing entitlements. We are looking at how Pulse entitlements will look in the coming quarters, but any existing customer that has current Avi entitlements with the current Avi SKUs are entitled to use Pulse.
Okay. So let's do the second part of demo, and I'll ask more questions that comes in. Okay.
Awesome. Sounds good. All right. So the second part of the demonstration that we wanted to take a look at was centered around zero-touch support or proactive support. Now, to demonstrate that, I have my application that is running on 2 service engines, and these service engines are up and running, and this service engine is currently servicing traffic. It's doing about 60, it's utilized to about 60% of CPU, and the application is running fine, it's running healthy, nothing's happening. Now, to demonstrate zero-touch support, I'm actually going to induce a failure on this service engine. What we will see happen is the service engine will fail, and the hope is the controller will detect the failure and automatically create the case and upload the relevant information for that issue and for that case. So for that, let me quickly go in and induce a failure. So bear with me for a second. All right, so I have induced a failure into this application, into this, my apologies, this service engine. And what we should see is in a second, this service engine should fail. And notice this TK API service engine, which currently is not servicing any applications. The moment this service engine went down, the virtual service was removed from that service engine, and it was instantly placed on the TK API service engine. Now, this demonstrates the self-healing aspect of the controller, where the moment that a service engine goes down or any application problem is perceived, controller will do the necessary things, the things that are necessary to rebalance those applications to make sure that the capacity constraints of that application are always satisfied. So now we can see the Pulse demo application is actually running on TK API service engine instead of the FUVSR. Now, let me actually go in to the FUVSR service engine. And what we will notice is if we look at the events, we will see that at around 8:40:31, there was a SE down event that happened. And this was a service engine failure event, which is a critical event, which does warrant a support case. It was hosting a VS called Pulse Demo. This is our application that it was hosting. And this is the metadata that is incredibly useful to figure out where was the failure, what was the failure, what got impacted, etc. Now, going back to this window, we saw TK API as the service engine that took over the traffic from the other service engine. Here we would see at around 8:40:31, there was a modified network call, the exact same timestamp. And in about 4 seconds, this service engine got the application Pulse Demo added to it. So in about 4 seconds, controller realized there is a failure that needs to be handled, and it programmed the service engine with the appropriate networks, etc., automatically. And it has started servicing traffic about the same level as what it was before on the other service engine. Now note, if there was no service engine available at this time, controller would have gone in and actually created a new service engine automatically. Now let's see what has happened to an alert. On that service engine failure event at 8:40:31, we see a zero-touch support alert being generated. Looking at the events in more detail, we will see at 8:40:31, there was the alert that got generated. And then in few minutes, there was a ALB services support case action, support case event that was generated. And let me take this ID and copy it in my clipboard. This is a support case ID in my VMware, VMware's support portal. And this is the Pulse API call that has gone from controller to Pulse to actually create this support case. This support case is created, and soon after, controller automatically is requesting to generate and upload a file attachment to that case. There are a couple of file uploads that will happen, and then we will get a success event to that attachment. Now let's go back. Now let's go to my VMware and see whether we can actually see that support case that was generated. I will log in to my VMware with my credentials. Once I log in to my VMware, let me go to support and my support requests. And let me paste what I had copied from the clipboard. This 2204 was, this 2204 was the support ticket that was created by controller. And now we could see that this 2204 issue has got all the relevant metadata automatically filled in. It's running on a VMware ecosystem. This was the FUVSR service engine that failed, and it was hosting the Pulse Demo application, etc. Also, we will see in view files, we will see that the relevant files that are needed to debug this issue would have been automatically uploaded to this support case. And let's wait for my VMware to pull up those files, and we could see this service engine tech support and events JSON that have been uploaded to the support case. This is incredibly powerful. When a failure happened, controller first remediated the problem, and at the same time, as soon as the alert got generated, it automatically triggered a support case, and it uploaded all the relevant information for this support case. And at this point, I should actually close this support request as a demo. Otherwise, my VMware will contact me and ask, sorry, what's happening. So let me actually go and close this request before I get a call from VMware support. You could see here that instantly the support request was created as soon as a failure was noticed. And now we could see the same view from controller as well. If we go to the support page, right from the controller will pull the relevant support cases that have been created by this controller. Looking at the case metadata, it is the same support that has been created automatically. Now you could use the same controller interface. This is the first workflow that we talked about, and you can actually create a support case right from here, and you can actually attach tech supports, etc. You could just ask the system to generate tech supports, etc., and to attach it to a case, and that would work in the same fashion as well. But with zero-touch support, admin does not have to do anything, and the failure would be remediated. Going back to the application, we again see that the service is fully restored, and now it's actually being serviced by another service engine that the controller automatically placed the application on. This concludes the demonstration that I had. And before we jump into Q&A, I just wanted to show a couple of slides that talk about security for Pulse as well as automation capabilities. Now, Pulse is built with security as top of mind. It's a vetted VMware cloud-ready secure service. Pulse does not store, as we mentioned, does not store any customer data, and controllers that register into Pulse are fully sandboxed. There are no credentials that are stored either on controller or on Pulse. And my VMware does the authentication transparently. Customers can also choose to use a forward proxy between controller and Pulse, and on that forward proxy, further security controls can be implemented if desired. Also, as mentioned, Pulse does not gather any information from the controller. Even if a service has been enabled, all workflows are initiated from the controller to Pulse. And in the event screen, we saw those ALB services events. Those were actually triggered by the controller going into Pulse and not the other way. And as an example, of, if Pulse has a new security update that it wants to publish to the controller will first get a notification from Pulse of the available update. And controller will then act on that notification and call a Pulse API to download the security update. And by default, none of Pulse services are enabled, and customers would really need to enable the desired services through the various service opt-ins. The second piece is Pulse is built with automation in mind, and with all services exposed over first-class secure REST APIs. The controllers, when directly integrated with Pulse, would deliver the best experience, of course. However, for customers who are unable to do so, unable to register controllers directly with Pulse, they can leverage the Pulse SDK to rapidly develop Pulse workflows and seamlessly integrate most services into their CI/CD pipelines. Pulse is built on secure APIs with object-level authentication, authorization using access tokens, etc. And registration credentials, etc. are never stored either on Pulse or controller. And controller always initiates APIs feeding into Pulse. That sums up today's talk, and I have a few resources that I'd like you to take a look at to learn more about Avi and Pulse. And Lei, I would be happy to take questions.
Yes, there's a question about the support. It says, can you adjust the support level yourself?
Yes, you can. Let me go back to the support tab, and once we create support, we can actually manage the severity level. And through the automated pipeline, the zero-touch support, we can also tweak the level of severity that we want to be inserted when the support case is created, of course.
Yep. Cool. This is a really cool demo. I learned a great deal about this, and I think this is the best a dream that a support personnel or a network engineer could imagine, right? And then as we said, that it is actually entitled with our existing customers today. So there should be no reason why, if you're on the line, enable it and try it out and see how it works for yourself. Otherwise, I'm going to point out a few of these resources. So you've already visited our webinar, and the KB articles that Rahu just showed during the webinar is available on avinetworks.com/docs. So we have a lot of good documentation there. Also, you can learn more about Avi Pulse there as well. The next natural step is for you to get your hands on dirty, is to join our hands-on labs. So we run these workshops, which is free to everybody to attend, to actually get a feel of the products itself. So it's, you can join our about a 90-minute session, so 30-minute introduction and 60-minute of lab, before you dive into a 4-day workshop, which really goes into the details of our product and architecture. And all of these are available to you as a free resource, just to try it before you commit to and start talking to our VMware accounts team. Okay, so again, thank you very much for your time attending this webinar. This is the recording and slides will be sent shortly after, and feel free to forward it to your coworkers. You know, if you find this content to be really going to be saving their life, right, and making their work easier, feel free to forward and contact us if you have any questions. Again, thank you very much for your time, and thank you, Rahu. This is a great presentation and demo.
Absolutely, anytime. Thank you, everybody, for joining.
Yeah, thank you. Bye.